it's not really vertical compliance, it's actually your stiffness of the frame kind of almost moulding itself to the terrain. And the original Soda was designed to be a very titanium feeling frame. The sole is actually quite a flexible, lively frame. So when we did the titanium one, as well as wanting it to be lighter, I wanted it to be more, more titanium-y than the Soda, than the sole, if you want. So with the sole, the down tube's 35mm OD, top tube's 32mm OD, the seat tube's 28mm OD. And with the Soda, we went for similar wall kind of thicknesses, but we went up a little bit. We went for a 40mm OD down tube, stuck with a 32mm top tube, went for a 32mm seat tube. So not a deal different. And it was quite a flexible frame, and for the first 2 or 3 years we sold it, we got great feedback, and really, people really loved it, and it was very, very light. I mean, it was down under 3 pounds for the small frame. But what happened is that riding progressed. Forks got stiffer. Bolt-through forks on trail bikes became more prevalent. Tyres got stickier. Tyre technology has got a lot to answer for in terms of how much stiffness has to be dialed into frames these days, because tyres stick to the floor harder. The fashion for shorter stems and wider handlebars, again, when we first started selling the Soda, it was like 25, 26-inch wide handlebars maybe, was where we were at. Whereas these days, I mean, I run 28-inch wide handlebars, so I'm a pretty big lad. That's a lot of load that you're suddenly throwing into your very potentially twisty frame. And we began to get feedback that people were not quite as confident on it anymore. So when we came to redesign it, I actually did a like-for-like comparison with the sole, and I brought the actual frame stiffness on that is only a little bit less than the sole now. It's very similar. And the key thing, and people really love it, they love the positivity of the ride, it's got enough stiffness to do its job. The key thing is that compared to the sole, as well, again, as being very, very pretty, it's 25% lighter. It's 3.3 pounds versus 4.4 pounds. So it just, it's stiff, it's light, so it just lights up when you hit the pedals. So it's one thing that I actually use a lot particularly when I'm designing across 2 different materials, is rather than just looking at the sectional properties, the I value, the second moment of area, and then trying to figure out all the stresses and everything like that. One thing that I quite often look at is just the Young's modulus times the I value, EI. And if just put that at the bottom of each little column of tubes versus load input, and it's a very, very easy, quick way just to use a spreadsheet to look up how much deflection you're likely to get against a known frame. I'll quite often have the sole at the start of my at the start of my columns, and I'll have whatever I'm working on running away from that, and then the delta to the sole, because I'm very, very used to that frame. And I'm thinking, and then it comes down to a judgment. Is that is 10% less than the sole good? Is this a more aggressive frame? Is 50% more too much? And you make a call, and you get a prototype, and you test it. I mean, one of the things that I can't stress enough is that as much science as there is in terms of the stress analysis and making it not fall apart, and things we're going to talk about later in terms of handling and suspension and things like that, at the end of the day, you've got to ride it. You just have to ride it, because it's the combination of everything that makes the difference. I mean, we've been playing around with some geometry this summer to see whether we could improve on what we've got with the sole. And one thing we did, which was really surprising, is we had a bike with an adjustable bottom bracket height. Everything was identical to the sole apart from the bottom bracket height. And we couldn't tell the difference. It was like a half-inch difference. People told you a bike's got a half-inch lower bottom bracket. People, most people who ride will go, surely that'll make a difference. Surely that'll corner more easily. Surely that'll, hold its line better. But as part of that package, it didn't make much of a difference. Whereas maybe, you know, maybe on a suspension bike with, you know, with slacker angles, with, you know, with more going on in terms of, you know, the bike, you know, the actual bike moving around, lower bottom brackets do seem to make a difference, and that's something we have checked out. But it was interesting that something that a lot of people talk about being so important, it's not, when someone says, oh yeah, it's the low bottom bracket on that makes it handle great. It's not. It's the fact that the low bottom bracket works, or the bottom bracket height works with the head angle and the front centre and where the rider is on the bike, and the fact that it's got these bars and not those bars. And it's a whole package. It's not just one particular element overriding all others. So, that was materials. We'll do a little bit on handling. Now, what I'm going to do here is just talk a little bit about front end, just the science of front end handling, because it's something that's talked about quite a lot in bikes at the moment, particularly with the advent of 29-inch wheels. Most mountain bikes have ostensibly 26-inch diameter wheels around the edge of the tyre. But there is a movement to move to 29-inch wheels, and I don't think anyone's going to replace one with the other, but yeah, 29s are here to stay. Thing is that it's only recently that they've actually started handling anything like a proper bike, and the reason for this is trail. Now, up here, the top two diagrams are the same fork offset or rake, so the distance between the perpendicular distance between the steering axis and the wheel axle is the same, and all we've done is change the head angle. You've got shallow head angle, you get lots of trail, and the trail is the distance from where the steering axis hits the ground compared to the contact patch of the tyre. So with a lot of trail, you've got a slack head angle, a lot of trail. That means it's very stable, and it takes quite a lot of effort to move it away from the straight ahead. And you also get a phenomenon called wheel flop, where after a certain point, it'll suddenly flop over on you, and that's to do with how quickly the contact patch moves to the steering axis after you've started turning the handlebars. But anyone who's ridden a bike or ridden a few bikes will recognise this. You get a bike with a steep head angle, that's not got very much trail. There's very little self-centering there, and it's very easy to effect direction changes. On the bottom picture, what we have is the same head angle and not very little fork offset, lots of fork offset. The counterintuitive thing here is that low fork offset equals lots of trail. So smaller fork offsets make things more stable. The problem that 29ers had was probably the closest example to a regular mountain bike, a 26-inch wheel mountain bike, is this third diagram here, the bottom left. It had a reasonable amount of trail, not very much fork offset, and you just governed how much stability or not stability you wanted with the head angle. Because with the advent of suspension forks, suspension manufacturers basically dictate the fork offset. You know, as a frame designer, you can't actually change that. You're completely at the mercy of what forks you buy. And about several years ago, fork manufacturers all decided that about 1.5 inches, 38mm, was the fork offset they were going to use for 26-inch wheel forks, which isn't very much. So that's that. What happened with 29-inch wheels, if you think, effectively with a 29-inch wheel, you're leaving everything where it is, but you're moving the ground 35mm further away from you're moving the ground down 35mm, the wheels got bigger. So what that's obviously going to do, because the steering axis is